far above the noise of cities. Beyond the glow of streetlights and passing headlights, the night sky still carries one of the oldest experiences a human being can have. A person looks upward into darkness and sees points of light that seem almost impossibly calm. The stars do not hurry. They do not announce themselves. They simply remain there, patient and silent, as they have for countless generations before us. Long before modern astronomy, before telescopes and observatories and spacecraft drifting through the outer planets, ancient people slept beneath the open sky with no separation between themselves and the universe above. In many parts of the world, the Milky Way was bright enough to cast a faint shadow across the ground. On moonless nights, thousands upon thousands of stars stretched from horizon to horizon like frozen dust suspended in black water. And perhaps one of the strangest facts about stars is that human beings evolved beneath them for nearly all of history. Yet even now, after centuries of scientific discovery, they still retain their mystery. A star can appear delicate from Earth, small, quiet, almost decorative. But a single ordinary star contains forces so immense that the human mind struggles to truly absorb them. Inside every star, matter is being crushed by gravity with unimaginable pressure. At the core, atoms collide so violently that hydrogen becomes helium. In that process, tiny amounts of matter are converted directly into energy. The result is light, heat, radiation, and the steady glow that can travel across space for millions of years before reaching someone standing quietly in a backyard at midnight. Even our own sun, which feels warm and familiar against human skin, is a colossal nuclear furnace containing more than 99% of all the mass in our solar system. More than 1 million Earths could fit inside it. And yet, compared to other stars in the universe, the Sun is considered remarkably ordinary. There are stars so large that if one replaced our Sun, its outer atmosphere would stretch beyond the orbit of Mars. Some stars shine hundreds of thousands of times brighter. Others are so dense that a spoonful of their material would weigh more than a mountain. The universe, it seems, is not economical with scale, but the stars do not reveal this immediately. To the naked eye, they appear peaceful, gentle, almost intimate. Their true nature hides behind distance, and distance is one of the great themes of astronomy. When you look at a star, you are not seeing it as it is now. You are seeing ancient light arriving late. Light moves incredibly fast, faster than anything else known in the universe, traveling nearly 186,000 miles every second. Even so, space is so vast that starlight still requires years, centuries, or millennia to cross it. The nearest star beyond our Sun, a small red star called Proxima Centauri, is more than 4 light-years away. The light entering human eyes tonight began its journey before many children currently alive were even born. Other stars, visible in the night sky, are much farther. Some are hundreds of light-years distant. Their light left long before the invention of electricity, before airplanes, before photography. In rare cases, a star, visible to the naked eye, may no longer even exist. A massive star can explode in a supernova, ending its life in catastrophic brilliance, while its light continues traveling outward through space long afterward. Entire generations might continue seeing the star peacefully shining overhead without realizing they are looking at a ghost of the past. There is something quietly humbling about this. The night sky often feels immediate, but in reality it is ancient beyond ordinary comprehension. Looking upward is not only an act of observation, it is an act of time travel. Astronomers sometimes describe telescopes as machines for looking backward through history. The farther into space they peer, the farther into the past they see. Distant galaxies appear as they existed millions or billions of years ago, and stars themselves carry memories of cosmic history within them. Every atom heavier than hydrogen was forged inside stars. The calcium in human bones, the iron in human blood, the oxygen filling human lungs, all of it was created deep inside ancient stellar interiors, long before Earth existed. When massive stars die, they scatter these elements across space, enriching enormous clouds of gas and dust that eventually form new stars, new planets, and someday, living organisms capable of wondering where they came from. In a very literal sense, the universe learned how to build people by first learning how to build stars. This realization has changed the emotional relationship many people feel toward the night sky. Ancient cultures often imagined the heavens as separate from Earth, perfect and untouchable. Modern science revealed something stranger and perhaps more intimate. Human beings are not merely beneath the stars. They are made from the aftermath of stars, and still, despite all scientific understanding, stargazing remains deeply emotional in ways that are difficult to fully explain. Psychologists have studied the feeling of awe that emerges when people encounter immense natural phenomena, towering mountains, endless oceans, violent storms, or vast star-filled skies. Awe tends to shrink the sense of self, quiet mental noise, and alter the perception of time. People often describe feeling calmer afterward, more reflective, less trapped inside ordinary worries. The stars encourage a certain mental slowing. Perhaps this happens because space itself operates on scales that make human urgency seem softer around the edges. A stressful afternoon, an unanswered email, an awkward conversation from years ago. All these concerns exist within a universe where stars can live for billions of years. Some red dwarf stars, the smallest and most common type in the cosmos, may survive for trillions of years, far longer than the current age of the universe itself. Many of the red stars glowing faintly overhead tonight will still exist long after Earth's continents have shifted beyond recognition. Meanwhile, other stars live quickly and violently. Blue giant stars burn so intensely that they exhaust their fuel in only a few million years. In cosmic terms, this is almost brief. These stars blaze with extraordinary brightness, consuming themselves rapidly before ending in spectacular collapse. There is a strange parallel here with living things on Earth. Some lives move slowly and steadily. Others burn with astonishing intensity for a short time. Nature seems comfortable with both patterns. In fact, the universe appears surprisingly tolerant of impermanence. Stars are born inside enormous molecular clouds, drifting through galaxies like cold cosmic weather systems. Over time, gravity pulls gas together into denser and denser regions. Temperatures rise, pressure increases. Eventually, somewhere inside the darkness, nuclear fusion ignites. A star is born not with an explosion, but with balance. Gravity pulls inward. Energy pushes outward. For millions or billions of years, these opposing forces hold each other in delicate equilibrium, creating the steady light that crosses unimaginable distances to reach distant worlds. And all across the universe tonight, countless stars are entering existence for the very first time, hidden deep inside glowing nebulae where new solar systems slowly begin to form from dust, ice, metals, and silence. In some regions of space, these stellar nurseries are so immense that they span hundreds of light-years across. Through telescopes, astronomers observe pillars of gas illuminated by newborn stars hidden within them, their light filtering through cosmic dust like dawn through deep fog. The structures appear almost organic, resembling underwater clouds or drifting mountains suspended in darkness. One of the quieter surprises of astronomy is how soft the universe can look from a distance. Violent events shape the cosmos constantly. Stars collapse, galaxies collide, black holes consume matter with energies beyond comprehension. Yet the visual language of space is often gentle. Glowing clouds, pale spirals, faint rivers of light drifting through endless blackness. Perhaps this contrast explains part of the emotional pull of stargazing. The universe contains extraordinary violence, but from Earth it arrives mostly as silence and light. Even the stars themselves are not truly still. On human timescales, the constellations appear permanent. The familiar patterns seem fixed in place year after year, century after century. But every star in the sky is moving through the galaxy at enormous speeds. The shapes only appear stable because human lives are so brief in comparison. If someone could watch the night sky across tens of thousands of years, the constellations would slowly distort and rearrange themselves. Familiar figures would stretch apart. New patterns would emerge. The stars are wandering continuously through space, each carrying its own history and trajectory. Some travel alone. Others move in pairs or clusters, orbiting one another in gravitational dances lasting millions of years. Binary star systems are surprisingly common throughout the universe. In some cases, two stars circle each other so closely that their surfaces distort under mutual gravity, exchanging streams of hot gas across space. From far away, these systems appear as a single point of light. The night sky hides complexity behind simplicity. There are stars that pulse rhythmically, growing brighter and dimmer with astonishing precision. There are stars wrapped in expanding shells of gas from ancient eruptions. There are stars spinning so rapidly that they bulge outward at their equators, and scattered throughout the galaxy are collapsed stellar remnants, so strange that they seem almost fictional. Among the most remarkable are neutron stars. When a massive star dies, its core can collapse so completely that protons and electrons are crushed together into neutrons. The result is an object of unimaginable density, often no larger than a city. A teaspoon of neutron star material would outweigh entire human civilizations. Yet despite this density, neutron stars can rotate hundreds of times every second, sweeping beams of radiation through space like cosmic lighthouses. Some emit pulses so regular that early astronomers briefly wondered whether they might be artificial signals from intelligent life. Instead, they discovered something perhaps even more astonishing: dead stars still speaking through rhythm and motion long after their original form disappeared. There is something deeply poetic in that idea, though astronomy itself is not poetry. Nature simply behaves according to physics, indifferent to whether humans find meaning in it, and still, meaning emerges. For thousands of years, people have used stars to navigate oceans, mark seasons, organize calendars, and orient entire civilizations. Long before GPS satellites or digital clocks, travelers crossed deserts and seas guided only by the sky. The star known as Polaris became especially important in the northern hemisphere because it appears almost fixed above Earth's northern axis. While other stars wheel across the sky during the night, Polaris remains nearly stationary, offering direction to anyone patient enough to look upward. Sailors once trusted their lives to this steady point of light, and unlike modern navigation systems, stars required no batteries, no signals, no infrastructure. The cosmos itself became a map. In many ways, it still is. Modern observatories can determine the chemical composition of distant stars simply by analyzing their light. Every element leaves a subtle signature, a pattern hidden within the spectrum. From enormous distances, astronomers can identify hydrogen, helium, carbon, oxygen, iron, and dozens of other elements without ever physically touching the star itself. It is remarkable that the universe allows this kind of understanding at all. Human beings evolved on the surface of a small rocky planet, orbiting an average star in one ordinary region of one galaxy among billions. And yet, through patience and mathematics and observation, the human mind learned to decode the chemistry of suns scattered across the cosmos. There is a quiet beauty in that partnership between curiosity and reality. The universe did not have to be understandable, but to some degree, it is. And perhaps nowhere does this become more emotionally powerful than when people encounter truly dark skies for the first time. In much of the modern world, artificial lighting has hidden the majority of stars from view. Entire generations grow up seeing only a fraction of the night sky their ancestors once knew intimately. But in remote deserts, high mountains, and isolated oceans, darkness still reveals the galaxy in astonishing detail. Under these conditions, the Milky Way no longer appears faint. It becomes a luminous band stretching overhead, dense with stars and dust clouds and glowing regions invisible from cities. People often describe the experience as disorienting, not frightening exactly, but deeply unfamiliar. The human brain evolved to interpret nearby environments, trees, faces, weather, movement through landscapes. But the fully visible night sky confronts the mind with genuine scale. Thousands of stars emerge at once, each separated by enormous distances, together forming a structure so vast that ordinary intuition begins to fail. The galaxy contains hundreds of billions of stars, and the observable universe may contain trillions of galaxies. Numbers like these eventually stop behaving like numbers. They become textures of thought rather than quantities the mind can truly hold. Yet, despite such immensity, stars also create feelings of intimacy. A child lying in grass during summer may stare upward at the same constellations once studied by ancient astronomers in Babylon, by navigators crossing the Pacific, by philosophers in Greece, or by travelers moving silently across deserts thousands of years ago. Civilizations rise and disappear beneath the same sky, empires vanish, languages evolve, entire belief systems transform over centuries. Yet overhead, the stars continue their slow movements almost untouched by human affairs. This continuity has always carried a certain comfort. Even during difficult periods of history, people continued looking upward. During wars, migrations, famines, and long ocean voyages, stars remained present above human uncertainty. Perhaps this is why stargazing so often feels reflective rather than merely scientific. The sky encourages perspective without forcing conclusions. Some people look at the stars and feel small. Others feel connected. Some experience loneliness. Others experience relief. The universe itself offers no interpretation. It simply exists in overwhelming abundance, waiting quietly for observation. And among all the lights scattered across the night, there are stars that may already possess planets of their own. Worlds circling them in darkness, oceans reflecting unfamiliar constellations beneath alien skies no human being has ever seen. For most of human history, the existence of planets around other stars belonged more to philosophy than science. People wondered whether distant suns might possess worlds of their own, but there was no way to know. The stars remained too far away, their glare too bright, their surrounding systems hidden beneath distance and darkness. Then, gradually, technology became sensitive enough to notice tiny disturbances. A star would dim ever so slightly as a planet crossed in front of it. Another would wobble subtly under the gravitational pull of unseen worlds. Through these delicate measurements, astronomers began discovering planets orbiting distant stars by the thousands, and many of them turned out to be stranger than anyone expected. There are planets where iron may fall as rain through burning atmospheres. Worlds larger than Jupiter orbiting so close to their stars that a year lasts only a few days. Frozen planets drifting without any star at all, wandering alone through interstellar darkness. Some orbit binary stars, where two suns rise and set in the same sky. Others exist in regions scientists call the habitable zone, where temperatures might allow liquid water to exist. These worlds attract particular fascination because water carries such deep associations with life on Earth. Yet even if life exists elsewhere, the distances remain staggering. Radio signals traveling at the speed of light would still require years, decades, or centuries to cross the spaces between stars. The galaxy may be crowded with worlds, but space itself keeps them separated with immense silence. This silence has a profound emotional quality. The universe is not noisy in the way many people imagine. In films, spacecraft roar through explosions and rushing debris, but actual space is almost entirely soundless. Without air to carry vibrations, most cosmic events unfold in complete silence. A supernova capable of briefly outshining an entire galaxy would erupt without any audible sound to a distant observer. Colliding galaxies would drift through one another almost noiselessly over millions of years. The stars themselves burn quietly. Perhaps this contributes to why the night sky feels so calming. Human environments are filled with mechanical sound. Engines, alarms, conversations, traffic, machines. But the cosmos beyond Earth unfolds with enormous patience and near total silence. Even time behaves differently among the stars. On Earth, human life is organized around days, seasons, aging, deadlines, and clocks. But in astronomy, time stretches outward into scales almost impossible to emotionally grasp. Stars are measured not in years, but in millions and billions of years. The Sun itself is roughly halfway through its life, already about 4.6 billion years old. Deep inside its core, hydrogen continues slowly fusing into helium, maintaining the delicate balance between gravity and outward energy. One day, billions of years from now, that balance will change. The sun will expand into a red giant, growing so large that the inner planets may be consumed entirely. Oceans on Earth will vanish long before that final stage arrives. The atmosphere will transform. The surface will become unrecognizable. Eventually, the outer layers of the sun will drift away into space, forming a glowing shell called a planetary nebula, while the remaining core cools into a white dwarf, a dense stellar ember slowly fading over unimaginable spans of time. And strangely, this knowledge often does not create despair. Instead, many people experience a kind of peaceful acceptance when thinking about stellar life cycles. Stars are born, evolve, transform, and disappear according to the same universal laws governing everything else in nature. Impermanence is not treated as failure by the cosmos. It is simply part of the process. Some of the atoms currently inside human bodies were once inside stars that died billions of years before the sun formed. Someday, Earth's material will also scatter and recombine into new forms. Astronomy quietly dissolves the illusion that anything in the universe is truly separate from everything else. The iron in blood and the iron in distant stars obey the same physics. The calcium in ancient seas and the calcium forged in stellar interiors share the same origin story written across cosmic time. This realization can feel oddly comforting late at night, especially beneath clear skies where the stars appear endless and unreachable at once. There is another curious fact about stars that astronomers often mention. Most stars in the universe are red dwarfs, small, cool stars that burn their fuel extremely slowly. They are dim compared to larger stars like the Sun, which makes them difficult to see with the naked eye despite their overwhelming abundance. In other words, many of the universe's stars are hidden from ordinary human vision. The night sky, beautiful as it appears, is only a partial portrait of reality. Even the Milky Way contains enormous dark clouds of dust, blocking light from entire regions beyond them. Infrared telescopes reveal hidden stars inside these clouds, glowing softly where visible light cannot pass. Again and again, astronomy reveals that much of existence remains concealed beneath appearances. The visible universe is only a fraction of the whole story. Dark matter, for example, cannot be seen directly at all. Astronomers infer its presence through gravity because galaxies rotate in ways that visible matter alone cannot explain. Something invisible surrounds and shapes galaxies across the cosmos. No one fully knows what dark matter is. And beyond that lies dark energy, an even stranger mystery connected to the accelerating expansion of the universe itself. The more carefully humanity studies the cosmos, the more the unknown seems to expand alongside knowledge. But perhaps this endless horizon of mystery is part of what keeps astronomy emotionally alive. If the universe were fully understood, the stars might lose some of their psychological depth. Instead, every discovery opens further questions. How many civilizations may exist across cosmic history? How many worlds have oceans beneath unfamiliar skies? How many stars have already died while their light continues traveling silently through space? Somewhere tonight, perhaps in a distant galaxy unimaginably far away, a star is collapsing at this very moment. Somewhere else, planets are forming from spinning disks of dust around newborn suns. Elsewhere, ancient light that began its journey before human civilization now crosses empty intergalactic space toward destinations it may never reach. And here on Earth, a person lies awake in darkness, looking upward, connected to all of it through light entering the eyes from across enormous distances. It is astonishing how little is actually required for stargazing. No advanced technology is necessary, no expertise, only darkness, patience, and attention. The stars ask almost nothing from human beings except stillness. Perhaps this explains why so many cultures associated the night sky with contemplation. Under the stars, the pace of thought often changes naturally. The mind begins widening beyond immediate concerns toward larger patterns. Time, existence, distance, mortality, continuity, yet the stars themselves remain indifferent to these reflections. They shine whether anyone notices them or not. A lonely lighthouse on a distant coast, a desert traveler resting beside cooling sand, a child staring upward through a bedroom window, an astronomer working quietly beneath observatory domes high in the mountains, all encounter the same ancient light, arriving from beyond human history. And overhead, scattered across the dark in silent abundance, the stars continue their slow and patient burning, each one carrying stories far older than the civilization currently watching them. Some of those stories began before Earth itself existed. Many of the stars visible in the night sky belong to populations far older than the Sun. Ancient objects formed during earlier chapters of galactic history. Astronomers can estimate stellar ages by studying brightness, temperature, motion, and chemical composition. Older stars often contain fewer heavy elements because they formed before generations of stellar explosions enriched the galaxy with more complex material. In a sense, stars preserve memory. Not memory in the human way, with emotions or experiences, but physical memory written into matter itself. A star's chemistry records the conditions of the universe at the time of its birth. By studying starlight, astronomers reconstruct events stretching back billions of years, piecing together the slow evolution of galaxies across cosmic time. The Milky Way, the galaxy containing our solar system, is itself an immense rotating structure of stars, dust, gas, and dark matter, spanning roughly 100,000 light-years across. From Earth's surface, its densest regions appear as a pale river of light because human eyes cannot separate the countless individual stars blended together. And there are so many stars within the Milky Way that if a person attempted to count one every second without stopping, it would take thousands of years to finish. Yet even our galaxy is only one among vast numbers. Modern telescopes observing deep space reveal galaxies scattered throughout the universe in staggering abundance. Spirals, ellipticals, irregular clouds of stars, some calm and orderly, others distorted from ancient collisions. Each galaxy contains its own history of star formation, destruction, and renewal unfolding over billions of years. Sometimes, when astronomers point telescopes toward seemingly empty patches of darkness, thousands of previously unseen galaxies emerge in the resulting images. What appears empty is often only beyond ordinary perception. This idea echoes throughout astronomy repeatedly. Darkness is not always absence. Silence is not always emptiness. Space itself, though vast and cold, contains hidden structure almost everywhere scientists look. Even between stars, there are drifting molecules, magnetic fields, radiation, and faint clouds of gas stretching across unimaginable distances. And still, despite all this hidden complexity, stars remain emotionally accessible in a way many scientific subjects are not. A person does not need advanced mathematics to feel something while looking at the night sky. Part of this may come from the strange balance stars create between familiarity and incomprehensible scale. The stars are always present, woven into ordinary human life. They appear above highways, suburbs, farms, forests, oceans, rooftops, and quiet neighborhoods. They belong equally to scientists and insomniacs, to ancient navigators and modern children. Yet at the same time, every star represents something almost beyond intuitive understanding. Take the star Betelgeuse, for example, glowing reddish in the constellation of Orion. It is so enormous that if placed where the Sun is, its outer layers would extend beyond the orbit of Jupiter. Inside that immense sphere, energy and matter churn continuously through processes difficult to fully imagine. And still, from Earth, it appears as a small reddish point suspended quietly in winter skies. Distance softens everything. Astronomy often transforms violent scales into gentle lights. There are stars whose surfaces boil with eruptions larger than entire planets. Stars wrapped in magnetic storms, stars ejecting streams of particles into surrounding space at millions of miles per hour. Yet because of distance, these extraordinary events arrive at Earth only as faint twinkling light. Even twinkling itself is not caused by the stars. It comes from Earth's atmosphere. As starlight passes through layers of moving air, it bends slightly in different directions, causing the stars to shimmer and flicker. Planets twinkle less because their apparent disks are slightly larger in the sky. It is quietly beautiful that part of what humans experience while stargazing is actually an interaction between the cosmos and Earth's atmosphere. The stars and the air above us collaborate to create the familiar shimmering of the night sky, and Earth itself is moving constantly beneath that sky. The planet rotates at roughly 1,000 miles per hour near the equator, while orbiting the Sun at about 67,000 miles per hour. Meanwhile, the Sun moves through the Milky Way, carrying the entire solar system with it. Human beings often feel physically stationary, but in reality, everyone is traveling through space continuously at enormous speed. Yet, because motion is shared collectively, it feels like stillness. There is something deeply calming about this hidden movement. Even during quiet moments, the universe remains active beyond perception. Galaxies drift, stars rotate, nebulae expand, invisible particles cross space. Entire solar systems orbit silently through darkness, and through it all, the night sky maintains its appearance of tranquility. Astronomers sometimes speak about stellar evolution, but the phrase can sound more dramatic than the actual process. Most stars change very slowly. If someone observed the same star night after night across a human lifetime, it would appear almost identical. Stars teach patience. Their transformations unfold across timescales far exceeding ordinary human awareness. Entire civilizations rise and disappear during periods when a star changes only slightly. This slow cosmic pacing affects the emotional atmosphere of astronomy. Unlike many sciences focused on rapid events or immediate outcomes, the study of stars encourages long perspectives. It reminds people that existence operates simultaneously on many layers of time. Human nervous systems evolved to respond to seconds and minutes. Weather unfolds over days. Forests evolve over centuries. Mountains rise over millions of years. Stars live for billions. The universe contains all these tempos at once. Perhaps this is why staring at the night sky can produce a subtle sense of release. Personal worries often exist inside extremely short timelines. Under the stars, the mind encounters scales so vast that urgency loosens slightly. Not because human life becomes meaningless, but because it becomes contextualized. A single human life is brief compared to stars. Yet consciousness itself remains extraordinary. The universe, after billions of years of stellar evolution, produced beings capable of studying the stars and emotionally responding to them. In a quiet way, the cosmos became aware of itself through living minds. Carl Sagan once reflected on this idea. Though even before modern astronomy, many cultures sensed some deep relationship between humanity and the heavens. Ancient myths connected stars to gods, spirits, ancestors, or cosmic order. Today, science offers different explanations, yet the emotional instinct remains similar. People continue searching the stars for orientation, meaning, and perspective. And perhaps the stars encourage this because they embody a rare combination of permanence and change. The night sky appears eternal, yet every star is temporary. Some are ancient, some are newly born, some are already dying. Nothing remains fixed forever. Even constellations are temporary arrangements created by viewpoint. The stars composing them are usually separated by enormous distances, unrelated except from Earth's perspective. Orion, Ursa Major, Cassiopeia, these patterns exist partly because the human mind naturally seeks recognizable shapes within complexity. This tendency is deeply human. The brain searches for order constantly, assembling narratives from scattered points of information. Under the stars, that instinct becomes visible. Humans draw hunters, animals, heroes, and myths across random distributions of distant suns, and perhaps there is something comforting about that too. Against overwhelming scale, the mind responds not with silence alone, but with imagination. For ancient civilizations, constellations became stories carried across generations. They served as calendars, navigational tools, seasonal markers, and cultural memory woven directly into the sky. Long before written language became widespread, the stars helped preserve knowledge. The arrival of certain constellations before dawn signaled migrations, planting seasons, floods, or changing weather. In this way, the night sky once functioned almost like a living clock. People knew where they were in the year by watching which stars rose above the horizon. The heavens moved with extraordinary reliability, creating rhythms that connected human life to larger cosmic cycles. Even today, despite satellites and digital systems, many people still experience an instinctive awareness of seasonal skies. Winter constellations feel different from summer ones. Certain stars belong emotionally to particular temperatures, winds, or memories. The bright star Sirius, for example, has been noticed by human beings for thousands of years because of its intense brilliance. Ancient Egyptians associated its appearance with the flooding of the Nile. To others, it became the dog star, part of the constellation Canis Major. And though scientific understanding has changed dramatically since those ancient observations, the emotional experience of seeing Sirius rise into cold night air remains strangely continuous across time. The same light that entered ancient eyes still reaches Earth now. This continuity becomes even more striking when considering how old starlight truly is. On clear nights, people routinely observe photons that traveled across space for decades, centuries, or longer before gently arriving at the retina. Those particles of light crossed enormous emptiness without interruption, surviving dust clouds, magnetic fields, and gravitational distortions before ending their journey in human perception. Every glance at the stars is the conclusion of an ancient voyage. There is something deeply calming about this slow arrival of light. In modern life, information moves instantly. Messages appear immediately. News travels in seconds. Human attention is constantly accelerated. The stars belong to a different rhythm entirely. Nothing about astronomy feels rushed. A star may burn for billions of years. Galaxies drift gradually toward collisions that will unfold over immense spans of time. Even light, the fastest phenomenon known, requires years to move between neighboring stars. Perhaps the night sky offers psychological relief, partly because it exists outside ordinary human urgency. Under starlight, time feels wider. This widening effect has been noticed by philosophers, writers, travelers, monks, scientists, and insomniacs throughout history. People often describe a subtle mental quieting beneath clear skies, as though attention naturally stretches outward beyond immediate concerns. Modern neuroscience suggests that experiences of awe can temporarily reduce excessive self-focus. Vast environments encourage the brain to process information differently, shifting attention toward broader awareness rather than repetitive internal thought. And few environments are vaster than the stars. Even so, human beings rarely perceive the true darkness of the universe. Space itself is not brightly illuminated. Beyond Earth's atmosphere, the cosmos is overwhelmingly black because stars, despite their immense brightness, are separated by colossal distances. If someone drifted between galaxies, the surrounding darkness would feel almost absolute. This darkness is not hostile in the emotional sense people sometimes imagine. It is simply the natural background of the universe. Stars are islands of light within enormous expanses of shadow, and perhaps that contrast is part of what makes them beautiful. Light becomes more meaningful when surrounded by darkness. A single distant star visible through cold night air can feel surprisingly intimate, precisely because the surrounding sky is so vast and empty. Astronauts who have traveled beyond Earth often speak about the unusual appearance of stars in space. Without atmospheric distortion, the stars no longer twinkle. They shine with steady sharpness against deep blackness. Some astronauts describe this view as breathtaking. Others describe it as unsettling, because once Earth's atmosphere disappears, so does the comforting illusion that the sky is nearby. Space reveals itself as a profound abyss extending endlessly in every direction, and yet Earth itself becomes more precious from that perspective. Seen from orbit, our planet appears thin-skinned and fragile, wrapped in a delicate atmosphere glowing faintly against darkness. All human history, every civilization, language, conflict, discovery, love story, and forgotten moment exists within that narrow layer surrounding a small world orbiting one star among billions. Astronomy has a way of shrinking and enlarging human importance simultaneously. On one hand, the universe makes human scale seem tiny. On the other, conscious life becomes extraordinarily rare and valuable against such immense emptiness. The stars do not diminish humanity. They contextualize it. Perhaps this is why people continue feeling emotionally connected to the cosmos, even in highly technological societies. Scientific explanations did not erase wonder. If anything, modern astronomy deepened it. Knowing that stars are enormous thermonuclear spheres does not make them less beautiful. Understanding stellar evolution does not reduce the emotional impact of a clear winter sky. Knowledge and mystery coexist surprisingly well in astronomy. In fact, scientific understanding often reveals deeper layers of strangeness beneath ordinary appearances. Consider white dwarfs, the remnants left behind after stars like the Sun exhaust their fuel. These stellar cores no longer generate energy through fusion, yet they remain intensely hot for billions of years while slowly cooling through space. Or consider black holes, regions where gravity becomes so strong that not even light can escape. Many form after massive stars collapse under their own weight. Though invisible directly, black holes shape surrounding matter dramatically, bending light and distorting space-time itself. These are not fictional ideas or symbolic metaphors. They are real features of the universe, and still, despite their complexity, the stars retain emotional simplicity from Earth. A person standing alone beneath a clear sky does not need to calculate stellar spectra or gravitational equations to feel the quiet power of starlight. Sometimes the experience is almost wordless: a cold breeze moving through trees, distant insects or waves or city sounds fading beneath open sky, constellations emerging gradually as eyes adjust to darkness, the slow realization that every visible star is another sun, unimaginably distant and ancient. There is a reason human beings have paused beneath the night sky for so long. The stars invite contemplation naturally because they exist beyond ordinary possession. No one owns them, no one controls them. They remain inaccessible to everyday human ambition. Even the nearest stars are astonishingly far away. If the sun were reduced to the size of a grapefruit, the nearest star would still be thousands of miles distant on the same scale. Space is mostly emptiness separated by extraordinary distances that human intuition struggles to grasp emotionally. And yet light bridges those distances continuously. Tonight, as Earth rotates through darkness, photons from countless stars continue arriving silently across the atmosphere. Some began traveling before modern civilization existed. Others departed their stars while ancient forests covered regions now filled with cities. The night sky is a meeting place between present awareness and ancient events. Every visible star represents both distance and connection at once, and perhaps this duality explains part of the strange emotional tone stars create inside the human mind. They remind people simultaneously of isolation and belonging, impermanence and continuity, fragility and endurance. Far above the sleeping world, the stars continue burning with patient indifference, carrying on processes older than Earth itself, while illuminating the darkness just enough for human beings to wonder about their place among them. There is a subtle shift that happens when the mind stays with the stars long enough. At first, they appear as scattered points, simple and distant. But gradually, the sky begins to feel less like a backdrop and more like a layered structure, filled with depth that is not immediately visible. The darkness between stars starts to feel as significant as the light itself. Astronomers sometimes describe space not as empty, but as sparsely filled. That distinction matters, even in the most isolated regions of the galaxy. Particles drift through vacuum, photons travel endlessly, and faint fields of gravity shape motion across unimaginable distances. The universe is never truly still, even when it appears silent. One of the most fascinating aspects of starlight is that it carries information without needing language. A beam of light leaving a star contains signatures of temperature, motion, composition, and sometimes even hints of magnetic activity. By the time it reaches Earth, it has crossed vast stretches of time and space, yet it still preserves the physical conditions of its origin. In a sense, stars communicate through physics alone. There is no intention behind it, no message in the human sense, yet the information is there, embedded in light itself. When astronomers analyze spectra, they are not interpreting meaning, but reading structure. And still, for many people, it feels like a form of listening, a quiet translation of the cosmos. Some stars reveal their nature through subtle variations in brightness, others through shifts in color. Cooler stars glow deep red or orange, while hotter stars shine blue-white, their energy radiating at different parts of the electromagnetic spectrum. These differences are not merely visual, they reflect the internal conditions of nuclear fusion deep within each star's core. Temperature, mass, and age all shape the appearance of a star. Yet from Earth's surface, many of these distinctions blur into simple points of light. The night sky is, in a way, an abstraction of reality. What is seen is only a simplified version of what exists, and yet that simplified version is enough to inspire reflection across cultures and centuries. It is remarkable that something so physically distant can still feel emotionally close. Perhaps this is because stars occupy a rare position in human perception. They are both constant and unreachable. Unlike mountains or oceans, they cannot be physically approached. Unlike clouds or storms, they do not change quickly enough to demand immediate attention. They exist in a stable equilibrium between presence and distance. Even their movement across the sky is an illusion caused by Earth's rotation. The stars themselves are not rising or setting. The planet is turning beneath them, revealing different portions of the celestial sphere throughout the night. This hidden motion is one of the quiet truths of astronomy. Much of what appears to move is actually the observer in motion. The same principle extends far beyond Earth. Entire galaxies rotate, solar systems orbit galactic centers, and galaxy clusters drift through the expanding fabric of space-time. Motion is universal, but perception often disguises its source. Within this cosmic choreography, individual stars follow paths shaped by gravity. Some move in long elliptical orbits around the center of the Milky Way, taking hundreds of millions of years to complete a single revolution. Others pass through regions of space influenced by nearby stellar populations, subtly altering trajectories over time. Even the Sun is part of this movement, carrying Earth and the rest of the solar system through the galaxy at immense speed. Yet there is no sensation of motion in everyday life, only the steady familiarity of the sky. This disconnect between cosmic motion and human perception adds another layer to the calmness of stargazing. The universe is dynamic, yet it feels still. Some stars exist in densely packed regions called star clusters, where thousands of stars form from the same cloud of gas and dust. These clusters can be open, loosely bound groups that gradually disperse over time, or globular clusters, tightly packed spheres containing some of the oldest known stars in the galaxy. Globular clusters are particularly striking. They orbit the Milky Way's center in wide loops, containing stars that may be nearly as old as the galaxy itself. Within them, stellar densities are so high that the night sky from a hypothetical planet inside such a cluster would be filled with brilliant stars far brighter than anything seen from Earth. Yet even in such crowded regions, the distances between individual stars remain vast on human scales. Space rarely allows contact, only proximity measured in astronomical terms. There are also runaway stars, ejected from their original systems due to gravitational interactions or supernova explosions. These stars travel through the galaxy at extraordinary speeds, isolated from their birthplaces, moving alone through interstellar space. Their existence adds a quiet sense of motion to the galaxy, as if stars themselves are subject to unpredictable currents within the larger gravitational field. And still, from Earth, they appear indistinguishable from the rest. The night sky hides nearly everything about the individuality of its stars. Perhaps that is part of its calming nature. Complexity exists, but it is softened by distance. Violence exists, but it is translated into light. Motion exists, but it becomes stillness through perspective. Even the idea of near and far begins to lose intuitive meaning when dealing with interstellar scales. The nearest stars are still so distant that their light requires years to arrive. And yet, in cosmic terms, they are our neighbors. The galaxy is structured like a vast, thin disk where stars are separated by enormous gaps of space, yet still part of a shared gravitational system. Between these stars lies the interstellar medium, thin clouds of gas and dust, sometimes dense enough to form new stars, sometimes so diffuse that they approach perfect vacuum. These regions are the raw material of future stellar generations. Stars are not isolated entities. They are part of a continuous cycle. They form from clouds, live for billions of years, and return material back into space when they die. That material becomes the foundation for new stars, new planets, and eventually new possibilities for complexity. In this way, the universe is constantly recycling itself. Nothing remains entirely separate for long periods of cosmic time. Even light, though it travels freely, eventually encounters matter, is absorbed, re-emitted, or scattered into new directions. Energy flows continuously through the universe in changing forms, never truly stopping. And within this ongoing transformation, stars remain one of the most stable and recognizable structures. They are temporary on cosmic scales, yet enduring on human ones. A single lifetime experiences them as permanent. A galaxy experiences them as changing populations. This difference in perspective is central to astronomy. Scale determines meaning. When viewed across billions of years, stars appear as fleeting events. When viewed across seconds and minutes, they appear eternal. The mind shifts between these scales effortlessly under the night sky, without needing to consciously calculate anything. And in that shift, something unusual happens. The boundaries of personal thought begin to soften. Immediate concerns fade slightly into the background, replaced by a broader awareness of existence unfolding at multiple layers of time. There is no instruction in the stars, no demand, no urgency, only continuity, only light arriving from distant fires that began long before human awareness existed. And as night deepens and more stars become visible through darkening skies, the universe reveals itself not as a place of answers, but as a place of ongoing processes, quietly unfolding far beyond the limits of immediate perception, continuing their slow and silent work across the vastness of space. As the night deepens further, the boundary between individual stars begins to soften even more. What once looked like separation starts to feel like continuity. The sky is no longer perceived as isolated points, but as a single, vast field of ancient light, layered across different distances and times. Some of that light is incredibly old. Some is relatively young. But all of it arrives together in the same quiet moment of observation. Astronomy often reveals this kind of temporal layering. The universe does not present itself in a single frame of time. Instead, every glance upward is a composite image built from countless moments in cosmic history. A nearby star might be sending light from only a few years ago, while another point in the same view may represent a star that no longer exists in its original form. Yet the human mind processes it all at once, as a unified sky. This creates a subtle paradox. The stars feel present, but they are also deeply absent. They are here in appearance, yet far away in reality. They are alive in light, yet possibly long gone in physical form. The night sky becomes a kind of emotional bridge between presence and distance, between now and then. Even the concept of now begins to lose clarity when extended across space. In physics, simultaneity is not absolute. Events separated by great distances do not share a single universal present moment in the way human intuition assumes. Light travel time ensures that what is seen is always delayed, always slightly out of sync with what actually exists in distant regions. So when a person looks at a star, they are never seeing the star as it is, but as it was. This realization does not diminish the experience of stargazing. If anything, it adds a layer of depth to it. The sky becomes a living archive of time itself, where different eras of the universe coexist in a single view. Some stars visible tonight may no longer exist in their current form. Others may have changed dramatically since the light left them, and still others may be shining exactly as they were, unchanged for millions of years, maintaining stable fusion deep within their cores. Stability and transformation exist side by side in the stellar population. Among the most stable are main sequence stars like the Sun, steadily converting hydrogen into helium in a long equilibrium that defines most of a star's life. This phase can last billions of years, creating long periods of relative consistency in the galaxy. But even stability in astronomy is temporary. Eventually, every star evolves. What changes is not abrupt in most cases, but gradual, unfolding through internal shifts in pressure, temperature, and composition. A star does not simply end, it transforms. This idea of transformation without sudden disappearance is one of the most consistent patterns in astrophysics. Energy is redistributed, matter is rearranged, and structure evolves, but nothing simply vanishes without trace. Even when a star dies violently in a supernova, it leaves behind remnants, neutron stars, black holes, and expanding clouds of enriched material. These remnants become part of future cosmic cycles. In this sense, stars do not end so much as they are redistributed, and the universe carries those remnants forward. It is easy to think of space as empty, but it is more accurate to think of it as continuously inhabited by traces of past events. Radiation, dust, magnetic fields, cosmic rays, and gravitational influences fill regions between stars with faint but persistent structure. Even darkness in space is not absolute emptiness. It is simply low density. This subtle difference becomes important when considering how stars are born. New stars emerge from regions where density slightly increases, where gravity slowly gathers material over long periods of time. These regions are often cold and dark, making them difficult to observe in visible light, but infrared observations reveal hidden activity, collapsing clouds forming protostars, and disks of material gradually flattening into future planetary systems. The formation of a star is not a sudden ignition, but a slow accumulation of conditions reaching a threshold where nuclear fusion can begin. Once that threshold is crossed, a new star begins its long life, and somewhere else in the galaxy, another star may already be approaching its final stages, expanding or collapsing depending on its mass and internal structure. This simultaneous cycle of birth and death gives the galaxy a quiet sense of continuity. Nothing is static, yet nothing is abruptly interrupted. Everything moves through phases that overlap across vast timescales. Even galaxies themselves are not permanent structures in the absolute sense. They evolve, merge, and reshape over billions of years. The Milky Way is currently on a slow collision course with the Andromeda galaxy, though this event will unfold so gradually that no single human lifetime will notice it directly. The stars within those galaxies will be redistributed into new gravitational patterns, forming a different cosmic structure entirely. Yet even that transformation is far in the future, and the night sky as seen from Earth today remains unchanged on human timescales. This stability contributes to the psychological calmness often associated with stargazing. The sky provides a rare experience of consistency in a world where most things change quickly. While human life is filled with rapid transitions, the stars move at a pace that feels almost timeless. They do not react. They do not interrupt. They simply remain. This does not make them passive in a scientific sense, but it does shape how they are perceived. Under clear skies, especially in quiet environments far from artificial light, the stars can create a sense of expanded attention. The mind begins to slow its focus on immediate detail, and instead drifts toward broader patterns. Distance, scale, continuity, thought becomes less fragmented. There is also a subtle physiological component to this experience. Reduced light levels at night influence circadian rhythms, signaling the body to prepare for rest. In natural darkness, melatonin production increases, gently guiding the mind toward sleep. The presence of stars does not interrupt this process, it coexists with it. The result is a unique mental state where awareness and relaxation overlap. A person can remain awake while gradually entering a calmer cognitive rhythm, with thoughts becoming less urgent and more observational. In such moments, the stars function less as objects of analysis and more as stable reference points within a larger field of quiet perception. They do not demand attention, yet they hold it gently. And as the night continues, the sky slowly rotates, bringing new stars into view while others drift below the horizon. The overall structure remains familiar, but the details shift in subtle ways, reinforcing the sense of gentle motion across a stable framework. Each moment under the stars is slightly different from the last, yet the experience feels continuous. This continuity, combined with immense scale and quiet light, creates one of the most enduring experiences available to human perception. A simple act of looking upward becomes a connection to distances measured in light years, to histories measured in billions of years, and to processes that continue long after individual moments of awareness have passed. And through it all, the stars remain, burning steadily in the cold silence of space, offering no explanation, no interruption, only light that has traveled across unimaginable distance to arrive softly in the darkness of a single night. As the sky continues its slow rotation, the experience of stargazing begins to shift once more. The mind, having grown accustomed to the presence of distant light, starts to notice subtler patterns that were always there but not immediately apparent. Faint variations in brightness, slight differences in color temperature, regions of the sky where stars cluster more densely, and others where darkness seems to stretch deeper. What was once a uniform field of points gradually becomes a structured landscape. Astronomers describe this structure in terms of galactic geometry, but to the naked eye it appears more intuitive than mathematical. The Milky Way arcs overhead like a soft river of light, not because it is truly a river, but because Earth is embedded within a flattened disk of stars. Looking along the plane of the galaxy reveals more stars in every direction, producing that luminous band across the night. In darker regions, away from this plane, space appears more open. Fewer stars are visible, and the darkness between them feels wider, almost like depth rather than absence. This contrast between density and emptiness gives the sky a quiet dimensionality. It is not a flat surface. It is layered. And yet, even with this growing awareness, the experience remains calm. The complexity does not overwhelm. It unfolds gradually, like a slow reveal that never demands urgency. Some stars in the sky are part of moving groups, traveling together through the galaxy after forming from the same stellar nursery. These associations drift apart over time, stretched by gravitational forces until their shared origin becomes less visually obvious. Still, their motion carries traces of their shared beginning. Astronomy often uncovers these hidden relationships. Stars that appear unrelated from Earth may actually share a common history billions of years old. Others that appear close together may be separated by vast distances, aligned only by perspective. The sky is full of coincidences shaped by geometry. Even the brightness of stars can be misleading. A star that appears faint may actually be incredibly luminous but far away, while a brighter star might be relatively close but less energetic. Distance and intrinsic brightness interact in ways that make perception an unreliable guide without measurement. This is one of the quiet lessons of astronomy. Appearance alone rarely tells the full story. Behind every point of light lies a combination of physical factors: mass, temperature, composition, distance, and evolutionary stage, all shaping how that star appears from Earth. And yet, despite this complexity, the human experience of starlight remains simple. There is a reason for that simplicity. Human perception evolved in environments where immediate survival mattered more than cosmic accuracy. The brain prioritizes patterns that are useful on small scales: nearby movement, changes in light, recognizable shapes. The stars exist far beyond those scales, which is why they appear as simplified points rather than detailed objects. The night sky is, in a sense, optimized for emotional and navigational interpretation rather than analytical detail. And still, Even without detail, it communicates something profound. Stars reveal that the universe is filled with persistent energy sources, each undergoing long-term transformations governed by consistent physical laws. They demonstrate that matter can organize itself into stable, luminous structures under the right conditions, and that these structures can persist for extraordinary durations. This persistence is part of what makes them calming to observe. In a world where most visible processes are rapid, speech, movement, weather, human activity, the stars represent a different category of existence. They operate on timescales so large that change becomes nearly invisible. A person can return night after night and see the same arrangement of stars, unchanged in any noticeable way. Yet beneath that apparent stillness, everything is in motion: nuclear reactions, gravitational shifts, orbital paths, galactic rotation. Stillness, in astronomy, is often just slow motion beyond perception. There are also variable stars whose brightness changes over time in predictable or irregular cycles. Some expand and contract rhythmically, altering their luminosity as their outer layers pulsate. Others dim due to orbiting companions passing in front of them from our viewpoint. These subtle variations remind observers that even the most stable-looking lights in the sky may contain internal dynamics invisible without careful measurement. And then there are the transient events. Occasionally, a new star appears where none was visible before. Historically, such events were called novae, or guest stars, recorded by ancient astronomers who noticed sudden changes in the sky. Today we understand that many of these events are supernovae, violent stellar deaths releasing enormous amounts of energy. For a brief time, a single exploding star can outshine an entire galaxy. Yet even such dramatic events, when observed from Earth, appear as distant points of light rather than overwhelming explosions. Distance again transforms intensity into subtlety. The universe, regardless of its internal violence, presents itself gently across space. As night progresses further, the atmosphere above Earth can also shift slightly. Temperature changes alter air density, affecting how starlight refracts. Stars may shimmer more intensely near the horizon, while those overhead appear steadier. The air itself becomes part of the viewing experience, shaping how distant light reaches the observer. In this way, stargazing is never purely external observation. It is always an interaction between Earth and space, between atmosphere and vacuum, between presence and distance. And as the hours pass, fatigue begins to blend with attention. The mind does not sharply transition from wakefulness to sleep when under the stars in quiet conditions. Instead, awareness slowly loosens, thoughts becoming less structured, drifting in and out of focus. The stars remain constant during this transition. They do not change in response to human perception. They do not become brighter or dimmer based on attention. They simply continue emitting light that has already traveled across immense stretches of space and time. Some of that light may have left its source before human civilization existed. Some may have begun its journey when Earth itself was still forming, a young planet surrounded by dust and debris. And yet it arrives here now, at this exact moment, intersecting briefly with consciousness before continuing onward into night. This intersection is fleeting but profound. It is a meeting between deep time and immediate experience, between cosmic scale and human perception, between the ongoing processes of the universe and the quiet awareness of a single observer beneath the sky. And in that meeting, nothing demands interpretation, nothing requires action. There is only observation, and the gentle realization that the universe has been unfolding continuously, long before attention arrived, and will continue long after it fades. The stars remain unchanged by being seen, but for the one who sees them, something subtle shifts. A sense of perspective that lingers even as the night grows softer, darker, and closer to silence. That lingering sense of perspective is difficult to describe precisely because it does not arrive as a conclusion. It arrives more like a widening of awareness. The stars rarely provide answers in the way people often seek them. Instead, they offer context. A concern that felt immense during the day may seem slightly different beneath a sky filled with ancient light. Not smaller in a dismissive sense, and not unimportant, but situated within a larger frame. The stars do not erase human experience. They simply place it alongside scales of time and distance that are otherwise easy to forget. Perhaps this is one reason why so many cultures throughout history connected the night sky with wisdom. Not because the stars themselves possess intentions or messages, but because they encourage a mode of thinking that is broader, slower, and less reactive. The universe does not rush. A cloud of gas may spend millions of years collapsing into a new star. A galaxy may require hundreds of millions of years to complete a single rotation. Even light, despite its incredible speed, can spend thousands of years crossing relatively small regions of the cosmos. Against such scales, the pace of human life feels extraordinarily swift. Entire generations pass in the time it takes a star to undergo the smallest fraction of its evolution. Yet human consciousness possesses something unusual: the ability to comprehend scales far beyond its own duration. A person may live only decades, but can contemplate billions of years. A mind confined to a single planet can imagine the structure of galaxies. Through observation and curiosity, awareness reaches far beyond the physical limits of the body. This ability may be one of the most remarkable outcomes of cosmic evolution. After all, the universe spent billions of years forming stars, planets, oceans, and complex chemistry before producing beings capable of studying the process itself. The stars were shining long before there were eyes to see them. For countless ages, light crossed space without witnesses. Then, gradually, on at least one small world, life emerged. Simple organisms evolved into more complex forms. Nervous systems developed. Awareness expanded. Eventually, creatures began looking upward and wondering. That sequence of events is astonishing when considered carefully. The same physical laws responsible for nuclear fusion in stars also governed the chemistry that led to living cells. The same atoms forged in ancient stellar interiors eventually became parts of brains capable of reflecting on their origins. In this sense, the story of the stars and the story of life are not separate narratives. They are chapters within the same larger process. The night sky often makes this connection feel more immediate. Standing beneath the stars, it becomes easier to remember that Earth is not isolated from the cosmos. It is a product of the cosmos. The rocks beneath our feet, the water in the oceans, the air in the atmosphere, and the elements within every living organism all emerged through cosmic history. The distinction between Earth and space is useful in everyday language, but nature itself draws no such boundary. Earth is space. It is simply a region of space where matter organized itself into mountains, rivers, forests, weather systems, and life. And overhead, the stars continue illuminating that broader context. Some of the most ancient stars known are nearly as old as the Milky Way itself. They formed when the universe was still young, carrying chemical signatures from an era when heavy elements were much rarer than they are today. These stars are like living fossils of cosmic history. They preserve evidence of conditions that existed billions of years ago, allowing astronomers to reconstruct events from epochs far beyond human memory. Yet, despite their age, many continue shining steadily. There is something quietly extraordinary about that endurance. A star can persist through the rise and fall of entire planetary systems. It can witness the formation of continents, the evolution of species, and the passage of geological ages without changing dramatically in appearance. Human history, by comparison, occupies only a tiny fraction of stellar lifetimes. If the age of the Sun were compressed into a single calendar year, recorded human civilization would occupy only the final moments before midnight on the last day. And still, those moments matter. Scale does not eliminate significance. A brief song can be meaningful despite its short duration. A sunset lasts only minutes, yet people travel great distances to see one. The value of an experience is not determined solely by its length. The stars remind us of this indirectly. Their immense lifespans provide perspective, but they do not invalidate smaller scales of existence. Instead, they reveal that reality operates simultaneously across many levels, each meaningful within its own frame of reference. A single heartbeat matters within a human life. A human life matters within a civilization. A civilization matters within planetary history. Planetary history matters within cosmic history. Each layer exists within larger layers, nested like patterns within patterns. The night sky quietly illustrates this structure. Looking upward, one sees individual stars. Behind them lies the galaxy. Beyond the galaxy lie other galaxies. Beyond those lie structures so large they challenge imagination itself. And yet every level remains connected through the same fundamental laws. Gravity shapes stars and galaxies alike. Atoms behave consistently whether found in distant nebulae or human cells. Light follows the same principles everywhere it travels. The universe displays an astonishing unity beneath its diversity. Perhaps that unity contributes to the sense of calm people often experience while observing the stars. There is reassurance in consistency. Across unimaginable distances, nature remains coherent. The stars are not random decorations scattered across darkness. They are expressions of underlying processes operating throughout the cosmos. As the night moves toward its deepest hours, some stars disappear below the horizon while others rise to replace them. The sky slowly rearranges itself, though the transition is gradual enough to feel continuous rather than abrupt. This rhythm has accompanied human beings for thousands of generations. Ancient travelers watched the same celestial motions. Farmers planned around them. Sailors navigated by them. Philosophers reflected beneath them. The technologies have changed. The understanding has deepened. But the experience itself remains remarkably familiar. A person stands beneath darkness and looks toward distant lights. The gap between ancient and modern suddenly feels smaller, because despite all advances in science, the stars still evoke many of the same feelings they always have: curiosity, wonder, humility, reflection, and a quiet awareness of belonging to something vastly larger than oneself. And perhaps that is one of the most enduring facts about stars. Not merely that they shine, not merely that they fuse hydrogen, create elements, or shape galaxies, but that across centuries and civilizations, they continue to invite the same simple act of attention: to pause, to look upward, and to recognize, if only for a moment, that beyond the noise of daily life, beyond the boundaries of cities and nations and generations, an ancient universe continues unfolding in silence, illuminated by countless stars whose light still travels patiently through the dark. That patient journey of light never truly stops. Even now, while much of the world sleeps, countless photons are crossing the darkness between stars. Some are passing through the outer edges of planetary systems. Others are threading their way through thin clouds of interstellar gas. Still others are moving through vast regions of nearly empty space, where distances are measured not in miles or kilometers, but in years. For light, there is no fatigue, no hesitation. A photon born within a stellar core may spend thousands or even hundreds of thousands of years slowly working its way outward through dense layers of plasma before finally escaping into open space. Once free, it begins a different kind of journey, traveling across the galaxy until it encounters something capable of absorbing it. Perhaps a cloud of dust, perhaps a distant planet, perhaps the retina of a person standing quietly beneath the stars. There is something remarkable about that possibility. A particle of light, created deep within a star, may spend ages crossing the universe only to conclude its journey within a moment of human perception. The scales could hardly be more different, yet somehow they meet. Astronomy is filled with these intersections between the immense and the intimate. A galaxy may contain hundreds of billions of stars, yet individual observers can form personal memories associated with specific constellations. A star may burn for billions of years, yet its light can become part of a single evening's experience. Vastness and closeness coexist constantly in the night sky. This duality helps explain why stars occupy such a unique place in human culture. Many natural phenomena inspire awe, but stars inspire a particular kind of awe. Mountains feel enormous, yet they can be climbed. Oceans feel immense, yet they can be crossed. Forests can be explored. Deserts traversed. Rivers followed. Stars remain fundamentally beyond reach. Even with modern spacecraft, The distances are almost inconceivable. The fastest human-made objects would require tens of thousands of years to reach the nearest stars. Entire civilizations could rise and disappear during such journeys, and so the stars preserve a quality that many things on Earth gradually lose as they become familiar. They remain distant enough to sustain mystery, not mystery born from ignorance alone, but mystery born from scale. Even when astronomers understand a process mathematically, the emotional reality of that process can remain astonishing. Knowing how stars form does not make star formation less extraordinary. Understanding nuclear fusion does not make a star feel ordinary. In many cases, scientific knowledge deepens wonder rather than replacing it. The universe consistently turns out to be stranger, larger, and more intricate than earlier generations imagined. For example, stars are not isolated from the fabric of space-time itself. Their mass bends the geometry around them. Every star creates a gravitational presence extending outward across enormous distances, influencing nearby matter and shaping the paths of planets, comets, asteroids, and other stars. Gravity is one of the quiet architects of the cosmos. Unlike light, it cannot be seen directly. Unlike sound, it cannot be heard. Yet it structures entire galaxies. A star exists because gravity gathers material together. A planet orbits because gravity holds it in motion. Galaxies maintain their form because gravity weaves countless individual motions into larger patterns. The night sky appears calm, but beneath that calmness lies an intricate network of gravitational relationships extending across unimaginable scales. Everything influences something else. Nothing exists entirely alone. Even stars wandering through apparently empty regions remain connected to the broader structure of the galaxy through gravity's invisible reach. This interconnectedness appears repeatedly throughout astronomy. Stars influence planets. Planets influence moons. Galaxies influence one another. Clusters of galaxies respond to even larger cosmic structures. Nature seems to favor relationships over isolation, and perhaps that observation resonates because human beings experience something similar in their own lives. Individuals exist within families, communities, cultures, ecosystems, and histories. Every life is shaped by connections extending beyond immediate perception. The stars reveal a cosmic version of that same principle. Nothing emerges from complete separation. Everything participates in larger patterns. As midnight drifts toward the early hours before dawn, the sky often becomes especially clear. Temperatures drop. Air currents sometimes settle. The atmosphere grows steadier, allowing distant stars to appear sharper and more defined. These are the hours when many astronomers prefer to observe. The world becomes quieter, human activity slows. The universe feels slightly closer, not physically closer, of course, but easier to notice. Modern life surrounds people with artificial illumination, constant information, and countless distractions competing for attention. The stars require something different. They reward patience rather than speed. One cannot rush stargazing. Eyes need time to adjust to darkness. Patterns emerge gradually. Faint stars become visible only after prolonged observation. The experience unfolds at its own pace. Perhaps this is one reason it remains so restorative. The night sky operates according to rhythms entirely independent of human schedules. The stars do not care about deadlines. They do not respond to notifications. They do not accelerate for convenience. They simply continue shining. And because of this, they invite a temporary departure from the accelerated tempo of modern life. Many people report that time feels different beneath a star-filled sky. Minutes seem longer. Thoughts become less fragmented. Attention settles. Psychologists sometimes refer to experiences like this as forms of soft fascination. Unlike activities that demand intense concentration, soft fascination gently holds awareness without exhausting it. Watching waves, observing clouds, listening to rain, or looking at stars can produce this effect. The mind remains engaged, but not strained. Active, but relaxed. This balance may explain why stargazing often feels both intellectually stimulating and deeply calming at the same time. The stars provide endless material for curiosity, yet they ask nothing in return. One can spend years studying stellar evolution, spectroscopy, and galactic dynamics, or one can simply sit beneath the sky and watch. Both experiences remain valid. The stars do not distinguish between expert and beginner. Their light reaches everyone equally. In that sense, stargazing is among the most democratic experiences available. The same sky extends above cities and deserts, mountains and coastlines, wealthy nations and remote villages. Conditions may vary, but the stars themselves belong to no single culture or generation. They are part of a shared inheritance stretching back through human history. Every civilization that has ever existed looked upward eventually. Every language developed words for stars. Every culture created stories about them. And despite enormous differences in geography, belief, and technology, the fundamental experience remains surprisingly similar. A human being encounters darkness. Points of light emerge overhead. Questions follow naturally. What are they? How far away are they? Why do they shine? What lies beyond them? Those questions have echoed across thousands of years, carried from one generation to the next beneath the same sky. And even now, despite all that science has discovered, some of those questions remain open. The universe continues expanding. New stars continue forming. Ancient stars continue fading. Galaxies continue drifting through the dark. And somewhere beyond the limits of current observation, countless stories of light and matter are unfolding unseen, waiting patiently in the vast silence of space. That vast silence is not empty of activity. It is simply activity unfolding on scales that rarely intersect with ordinary human experience. Somewhere within the Milky Way at this very moment, stars are being born inside cold molecular clouds. Elsewhere, ancient stars are exhausting the last reserves of fuel that have sustained them for billions of years. Planets continue orbiting their suns. Comets trace long, invisible paths through darkness. Entire star systems drift through the galaxy, each carrying its own history. The universe never truly pauses. Yet from Earth, particularly during the quietest hours of the night, it often feels as though it has. Perhaps this impression comes from the way starlight reaches us. Unlike the flashing lights of machines or the rapid movement of modern life, starlight appears steady. It does not demand attention. It waits. A star can shine above a sleeping town for the entire night without anyone noticing, and still it shines. There is something deeply reassuring about that consistency. Human experience is filled with uncertainty. Weather changes, circumstances shift, plans evolve, entire societies transform across generations. The stars change too, but on timescales so immense that they provide a rare sense of continuity. A person may return to the same location years later and find familiar constellations waiting overhead. The world below may be different. The sky often feels familiar. This familiarity has comforted travelers throughout history. Imagine a sailor crossing a dark ocean centuries ago. No engines, no electronic instruments, only water stretching beyond sight in every direction. Above, the stars provided orientation, structure, and reassurance. The same was true for desert travelers navigating vast landscapes where landmarks disappeared beneath darkness. The stars became companions of a sort, not because they possessed awareness, but because their reliability offered guidance. Even today, people often look upward during moments of reflection. A difficult decision, a quiet evening, a sleepless night, a celebration, a farewell. The stars have witnessed countless human moments without participating in them. They remain detached, yet somehow present. This combination of distance and presence is unusual. Most things that influence human emotions are nearby. Conversations, relationships, environments, and events occur within immediate reach. Stars influence perception from distances so vast that the mind can scarcely imagine them, and yet their emotional impact is undeniable. Part of this may arise from the contrast between permanence and transience. Human lives unfold quickly. Childhood becomes adulthood. Seasons pass. Years accumulate. Memories grow more distant. Against this constant movement, the stars appear enduring. Of course, astronomy reminds us that stars are not truly permanent. They evolve continuously, but their pace is so different from ours that they create an impression of stability. In reality, stability itself may simply be change occurring slowly enough to feel still. A mountain appears permanent, yet it erodes. A forest appears stable, yet individual trees grow and fall. A star appears eternal, yet fusion gradually transforms its interior. The universe is filled with processes that only reveal their motion when viewed across sufficient spans of time. This realization invites an interesting question. How much of reality escapes notice simply because it unfolds too slowly? Continents move, galaxies rotate, stars age, even the universe itself expands. Yet these processes remain largely invisible during a human lifetime. The stars remind us that perception is limited not only by distance, but also by timescale. What appears fixed may simply be moving beyond our ability to detect. What appears eternal may simply be evolving very gradually. And still, despite these hidden changes, the night sky retains its calming presence. Perhaps because human beings do not require complete understanding to experience wonder. A child looking at the stars and an astrophysicist studying stellar spectra may possess vastly different knowledge, yet both can experience the same quiet sense of fascination. Knowledge changes the details. It does not eliminate the feeling. In fact, the more astronomers learn, the more extraordinary many discoveries become. For example, stars are capable of producing planets in astonishing variety. Around distant suns, astronomers have discovered worlds unlike anything found in our own solar system. Some orbit two stars. Some possess years lasting only a few days. Some may have oceans beneath layers of ice. Others exist in conditions so extreme that familiar chemistry behaves in unfamiliar ways. The galaxy appears far more diverse than early astronomers imagined. And yet all these worlds emerged from the same basic ingredients: hydrogen, helium, gravity, time. Given enough time, simple materials organize themselves into extraordinary complexity. Stars are central to that story. Without stars, there would be no heavy elements. Without heavy elements, there would be no rocky planets. Without rocky planets, there would be no oceans, mountains, forests, or living organisms capable of contemplating the night sky. The stars are not merely objects in the universe. They are engines of possibility. Every atom of oxygen breathed by humans was forged in stellar interiors. Every atom of calcium in bones, every atom of iron in blood, every atom of carbon involved in life's chemistry ultimately traces its history back to stars. When astronomers say that people are made of star matter, they are describing a physical reality. The connection is literal, and perhaps that is one of the most beautiful discoveries modern science has revealed. For much of history, humanity viewed the heavens and earth as fundamentally separate realms. The stars belonged to one domain. Human life belonged to another. Astronomy gradually revealed a deeper truth. The distinction is largely an illusion. The same universe produced both. The same physical laws govern both. The same cosmic history connects both. Under a clear night sky, this realization can feel surprisingly personal, not because it places human beings at the center of the universe, but because it places them within it. The stars cease to be distant decorations and become part of a shared story stretching back billions of years, a story still unfolding. Even now, while Earth turns beneath the darkness, the galaxy continues its slow rotation around its center. The sun moves through space. Nearby stars follow their own trajectories. Light continues crossing immense distances. The universe remains active in every direction. Yet the experience of observing it remains wonderfully simple. Look upward. Wait. Allow your eyes to adjust. Notice the first stars emerging from twilight, then the second, then dozens more. Gradually, the sky fills with ancient light. And for a little while, the ordinary boundaries of daily life seem less rigid. The horizon widens. Time stretches. The mind settles into a quieter rhythm. Above, the stars continue their patient burning, indifferent to observation yet endlessly available to it, illuminating the darkness as they have for ages beyond counting and offering, without intention, one of the oldest and most enduring experiences available to the human mind. One of the remarkable things about that experience is how little it depends on circumstance. The stars appear above crowded cities and isolated deserts alike. They shine over mountain ranges, fishing villages, forests, oceans, and plains. They illuminate places where millions of people live, and places where no one has stood for centuries. Human history unfolds beneath them, yet the stars remain largely untouched by it. Empires have risen and fallen under the same sky. Languages have emerged, evolved, and disappeared. Entire civilizations that once studied particular constellations have faded into history, while the stars they observed continue shining. There is something quietly humbling about this continuity. Human beings often measure time through personal milestones, generations, or historical events. The stars encourage a different perspective. Their existence stretches across intervals so vast that familiar markers become almost invisible. 1,000 years can feel like an immense span within human history. To many stars, it is barely a moment, and yet those 1,000 years contain countless individual lives, each filled with experiences, relationships, discoveries, fears, hopes, and memories. The contrast between human timescales and stellar timescales is not a competition. It is simply a reminder that reality operates simultaneously across many levels. The universe is large enough to contain both. A single human conversation and the evolution of a star are equally real, even if they unfold at dramatically different speeds. This coexistence of scales may be one reason astronomy feels philosophical without trying to be. The stars do not offer lessons directly. They simply exist in a way that naturally invites reflection. For example, consider the age of the universe itself. Current scientific estimates suggest that the observable universe is approximately 13.8 billion years old. That number is so large that it resists intuition. Human minds are not naturally equipped to visualize billions of years. To make sense of such timescales, astronomers often compress cosmic history into familiar frameworks. If the entire age of the universe were represented as a single calendar year, the Milky Way would form in the early months. The Sun and Earth would appear in September. Complex life would emerge much later. Human civilization would occupy only the final seconds before midnight, on December 31st. And yet those final seconds contain everything familiar to us. Every city, every work of art, every scientific discovery, every story ever told. The stars reveal both the brevity and the richness of human existence. Far from making life seem insignificant, this perspective can make it feel more precious. Rare things often derive value from their rarity. Conscious experience, at least as far as current knowledge suggests, may be among the rarest phenomena in the universe. Stars are abundant. Awareness may not be. This possibility gives stargazing an interesting emotional texture. Looking outward toward immense distances often leads people to think inward as well. The universe becomes a mirror of sorts, not reflecting faces, but questions. What does it mean to exist within such vastness? How does consciousness arise from matter? Are there other observers elsewhere beneath other skies asking similar questions? Astronomy cannot answer all of these mysteries, but it can frame them beautifully. Every star visible in the night sky represents a potential center of its own system. Around many of those stars, planets almost certainly orbit. Around some of those planets, conditions may exist that resemble aspects of Earth. Around a fraction of those worlds, life may have emerged. The numbers involved are immense. The Milky Way alone contains hundreds of billions of stars. Even if only a small percentage host potentially habitable worlds, the total could still be extraordinary. And yet the distances between these worlds remain enormous. The galaxy is not crowded in the way a city is crowded. It is spacious beyond ordinary imagination. This combination of possibility and distance creates one of astronomy's most enduring mysteries. The universe appears capable of producing life. The stars provide energy, stability, and the chemical ingredients necessary for complexity. So where is everyone? This question, often called the Fermi paradox, remains unresolved. Perhaps intelligent civilizations are rare. Perhaps they are common but separated by vast distances. Perhaps they exist during different periods of cosmic history and rarely overlap. Or perhaps the answers lie in possibilities humanity has not yet imagined. For now, the stars remain largely silent on the matter, and there is something fitting about that silence. Not every mystery requires immediate resolution. Some questions become more interesting because they remain open. The night sky has always contained unanswered questions. Ancient observers wondered what stars were made of. Modern science eventually provided answers. Today, new mysteries have taken their place. What is dark matter? What is dark energy? How common is life beyond Earth? What lies beyond the observable universe? The horizon of knowledge continues moving outward. Every answer reveals additional questions waiting beyond it. In this sense, astronomy is not a journey toward a final conclusion. It is an ongoing conversation between observation and mystery. The stars occupy the center of that conversation. They are among the first objects humans studied scientifically, and they continue to drive some of the most advanced research ever conducted. Massive observatories track their behavior. Space telescopes analyze their light. Computers simulate their evolution. Yet the basic act of observing them remains unchanged from ancient times. Someone steps outside, looks upward, and wonders. The simplicity of that act is extraordinary. Many scientific disciplines require specialized equipment before observation can even begin. Astronomy certainly benefits from technology, but its foundation remains accessible to anyone with a clear sky. The stars do not hide themselves completely. They offer enough visibility to inspire curiosity long before detailed understanding becomes possible. Perhaps this is why they have maintained such a powerful presence throughout history. They are both approachable and unreachable at the same time. Visible, yet distant. Familiar, yet mysterious. Stable, yet constantly changing. Few things embody so many apparent contradictions so gracefully. As the night moves toward dawn, some of the brightest stars remain visible while fainter ones gradually fade against the approaching light. The eastern horizon begins to soften. Colors return slowly to the landscape. The stars that seemed dominant only hours earlier retreat into the brightness of morning, but they have not disappeared. They remain overhead, hidden by daylight. This simple fact carries its own quiet lesson. Absence is not always disappearance. Many realities continue existing beyond immediate perception. The stars remain present even when unseen, just as galaxies continue rotating whether observed or not, and light continues traveling whether anyone notices it. The universe does not require attention to continue unfolding, and perhaps there is comfort in that. Long after observers fall asleep, stars continue burning. Long after one night ends, countless others will arrive. The sky will darken again. Ancient light will return, and future generations, standing beneath those same stars, will experience many of the same feelings that have accompanied stargazing for thousands of years. Curiosity, perspective, wonder, and a quiet awareness of belonging to a universe far larger, older, and more beautiful than any single lifetime could fully comprehend. That awareness of belonging often emerges gradually rather than all at once. A person may spend years seeing the stars simply as part of the background of life. They appear after sunset, disappear after sunrise, and return again the next evening. Familiar, predictable, easy to overlook. Then, perhaps on a particularly clear night, something changes. The sky appears darker than usual. The air is still. More stars become visible than expected. The Milky Way stretches overhead in pale detail, and for a brief moment, the night sky is no longer merely scenery. It becomes a place. Not a place that can be visited in the ordinary sense, but a place the mind can inhabit through attention. This shift in perception is subtle, yet it has occurred countless times throughout human history. The stars reward sustained observation. The longer one looks, the more there is to see. At first, only the brightest stars stand out. Then fainter ones emerge. Constellations take shape. Differences in color become noticeable. Patterns begin connecting distant points across the darkness. Eventually, the observer realizes that what once seemed simple is actually layered with complexity. Astronomy itself followed a similar path. Ancient observers first catalogued visible stars. Later generations recognized planetary motions. Telescopes revealed moons, nebulae, and galaxies. Spectroscopy uncovered stellar chemistry. Modern instruments detect planets around distant suns and observe structures billions of light-years away. Each step revealed additional layers hidden beneath earlier understanding. And yet, despite centuries of discovery, the stars have not become less mysterious. In many ways, they have become more so. The more astronomers learn, the more apparent it becomes how much remains unknown. For example, stars are often described as individual objects, but many exist within elaborate systems. Some orbit companions, others belong to clusters. Many interact gravitationally with nearby structures in ways that influence their evolution over millions of years. Even a seemingly isolated star may possess a complex history involving stellar migrations, ancient encounters, and long-forgotten regions of the galaxy. Every star carries a story, not a story in the human sense, with intentions and characters, but a physical narrative written through time. A star begins within a cloud. It gathers mass, fusion ignites, it shines, it changes. Eventually, it transforms into something else. Different masses produce different endings, but the principle remains the same. Nothing remains fixed forever. This observation appears throughout nature. Rivers reshape landscapes, forests grow and decline, species evolve, stars transform. The universe seems less like a collection of objects and more like a collection of processes. Everything is becoming something. Everything is moving through time. The stars simply do so at a pace that allows humans to perceive them as stable. This perception of stability can be comforting. There is reassurance in looking at something that appears unchanged night after night. Even if science reveals hidden transformations beneath the surface, the visual continuity remains. Perhaps this is one reason people often associate stars with permanence, not because they are truly permanent, but because they outlast individual experience. A person may spend an entire lifetime beneath the same familiar constellations. Children grow older, cities expand, technologies evolve. The stars remain recognizable. They provide a sense of continuity that extends beyond personal memory. This continuity becomes especially meaningful when considering how many generations have shared the same sky. Every human who ever lived beneath darkness encountered stars. Ancient astronomers mapping the heavens by firelight, farmers watching seasonal changes, sailors navigating open oceans, travelers crossing deserts, scientists studying spectra, families lying in backyards during summer evenings. All participated in the same fundamental act, looking upward. The details differed. The experience endured. There are very few aspects of human life that stretch so consistently across history. Languages change, cultures evolve, technologies transform daily existence. Yet the stars remain among humanity's oldest companions, silent, distant, reliable. And because they have accompanied so much of human history, they often become connected with memory itself. Many people can recall specific nights associated with particular skies, a camping trip beneath unusually dark stars, a childhood evening spent searching for constellations, a moment of reflection during a difficult period of life, a quiet conversation beneath the night sky. The stars become part of those memories not because they actively participated, but because they provided a setting vast enough to hold them. Perhaps that is one of the hidden roles of the night sky. It creates space, not physical space. The universe already contains plenty of that, but psychological space. Space for reflection, space for perspective, space for thoughts that might otherwise remain crowded out by daily concerns. Modern life often compresses attention into short intervals. Notifications arrive, tasks accumulate, information flows continuously. The mind becomes occupied with immediate demands. The stars encourage a different mode of awareness. Their scale naturally slows thought. Their distance discourages urgency. Their silence leaves room for contemplation, and unlike many sources of calm, they do not require interpretation. One does not need to believe anything specific about the universe to appreciate a star-filled sky. The experience is available to anyone willing to look. Science enriches that experience by revealing deeper layers of understanding. But wonder itself requires no prerequisites. A child can experience it. An expert can experience it. The stars remain equally available to both. This accessibility is remarkable when considering what stars actually are: massive spheres of plasma, nuclear furnaces operating under immense gravitational pressure, objects capable of generating staggering amounts of energy. And yet from Earth they appear gentle, small points of light scattered across darkness. Distance transforms power into tranquility. A supernova visible from another galaxy may appear beautiful rather than terrifying. A giant star, larger than the orbit of Mars, becomes a tiny reddish dot. Immense energies arrive softened by scale. The universe often appears calm, not because it lacks intensity, but because of the distances involved. And perhaps there is something reassuring in that as well. The cosmos contains extraordinary forces, yet from Earth they manifest primarily as light. Light that travels, light that endures, light that links distant regions of space to moments of human awareness. As the deepest hours of night gradually give way to the subtle approach of dawn, the stars continue their patient work. Fusion continues within stellar cores. Galaxies continue rotating. New stars continue forming. Old stars continue fading. The universe remains in motion. Yet overhead, the sky still appears peaceful, and beneath that peaceful sky, observers continue the ancient practice that has connected countless generations across time, standing quietly beneath the stars, allowing their minds to wander outward into distances too large to fully imagine, and discovering again and again that the simple act of looking upward can make the universe feel both impossibly vast and strangely close at the same time. That strange closeness may be one of the most fascinating psychological effects of stargazing. By every physical measure, the stars are unimaginably distant. The nearest star beyond the Sun is separated from Earth by trillions of miles. Many visible stars are hundreds or even thousands of light-years away. Their true scale lies far beyond anything encountered in everyday life. And yet, when people look upward, they rarely experience those distances emotionally. Instead, the stars often feel immediate, present, almost familiar. A bright star rising above the horizon can seem less like an astronomical object and more like a companion to the night itself. This emotional contradiction reveals something important about human perception. The mind does not experience reality only through measurement. It also experiences reality through relationship. A star may be physically distant, but if it appears regularly throughout one's life, it becomes psychologically familiar. People recognize certain constellations the way they recognize landmarks. They learn seasonal patterns. They notice recurring appearances. Over time, distant objects become woven into personal experience. In this way, the stars participate in human memory, despite existing far beyond human reach. Perhaps that is why many cultures throughout history gave individual stars names. Naming creates connection. It transforms anonymous points of light into recognizable presences within the larger sky. Today, astronomy often uses catalog numbers and scientific classifications, yet many traditional names remain in use. They carry echoes of earlier generations who also looked upward and felt compelled to identify particular lights among the countless others. There is something deeply human about that impulse. The universe presents overwhelming complexity, and people respond by creating patterns, stories, and names that make it easier to navigate emotionally. Constellations emerged from that same instinct. The stars themselves are rarely connected physically, yet human imagination linked them together into shapes and narratives. Hunters are hunters, animals, heroes, ships, kings, creatures of myth. The night sky became a canvas onto which cultures projected meaning. Modern astronomy revealed that these patterns are largely products of perspective, but the emotional significance remains. The constellations remind us that observation is never entirely separate from interpretation. People do not merely see the universe, they experience it, and experience always includes imagination. Interestingly, science and imagination are not opposites in this context. Many scientific discoveries begin with the ability to imagine possibilities beyond current knowledge. Astronomers once imagined that stars might be suns like our own. Later evidence confirmed it. They imagined planets around distant stars. Eventually, those planets were discovered. Today, scientists imagine future possibilities that remain unconfirmed, Searching for answers through observation and evidence, the stars continue inspiring both rigorous investigation and quiet wonder. Few subjects unite those two experiences so naturally. A professional astronomer analyzing stellar spectra and a person lying beneath a clear sky can both feel a sense of awe, even though their knowledge differs dramatically. The sky accommodates both perspectives. In fact, one of the most beautiful aspects of astronomy is that learning more rarely diminishes the emotional experience. Consider what happens when someone learns that the stars visible overhead are not scattered randomly, but belong to a rotating galaxy containing hundreds of billions of suns. The sky becomes larger. Then they learn that the galaxy itself is one among countless others. The sky becomes larger still. Then they learn that much of the universe remains invisible, influenced by dark matter and dark energy that are not yet fully understood. The mystery deepens. Knowledge expands the horizon rather than closing it. This quality makes astronomy uniquely enduring. Some mysteries disappear when solved. Astronomical mysteries often reveal larger mysteries beyond them. The universe seems determined to remain more extensive than any explanation, and perhaps that endlessness contributes to the calming nature of stargazing. There is no expectation that everything must be understood immediately. The stars have existed for billions of years. They can wait. Human curiosity unfolds gradually, one generation at a time. Each era adds new pieces to a puzzle that remains incomplete. Ancient observers tracked motions. Later generations invented telescopes. Modern scientists deploy observatories into space. Future civilizations, if they exist, may discover realities that current humanity cannot yet imagine. The stars connect these generations through a shared object of attention. Across centuries, people continue asking questions beneath the same sky, and while the questions evolve, the experience remains recognizable. Darkness falls, the stars emerge, curiosity follows. There is something almost timeless about that sequence. Even the physical act of observing stars encourages a slower pace. Eyes adapt to darkness gradually. Faint objects require patience. The best observations often occur after long periods of quiet attention. The sky cannot be rushed. This stands in contrast to many aspects of contemporary life, where information arrives instantly and attention shifts rapidly between tasks. The stars operate differently. They reward stillness. They reward observation without urgency. Perhaps this is why many people find them soothing. Not because stars are inherently calming, but because interacting with them encourages behaviors associated with calmness, patience, focus, perspective, and sustained attention. The night sky becomes a kind of natural antidote to haste, and as awareness settles, subtle details emerge. A faint cluster previously unnoticed, a slight color difference between neighboring stars, the slow movement of a planet against the background constellations, a meteor tracing a brief line through darkness. These moments are often small, yet they feel significant precisely because they arise from careful observation. The stars teach a quiet lesson about attention. Reality contains more than is immediately visible. Many things reveal themselves only after sufficient time and patience. This principle applies far beyond astronomy. But under the night sky, it becomes especially clear. The universe does not announce all its details at once. It unfolds gradually, and perhaps that gradual unfolding is part of its beauty. As the Earth continues turning beneath the stars, entire regions of sky move slowly westward. Constellations rise and set, seasons alter which stars are visible. Over months and years, different portions of the galaxy become accessible to observation. The sky is never exactly the same twice, yet it remains familiar. Change and continuity coexist. This balance appears throughout the cosmos. Stars evolve while preserving recognizable patterns. Galaxies transform while maintaining structure. The universe expands while remaining governed by consistent laws. Perhaps this balance between change and stability is one of the reasons the stars resonate so deeply with human experience. Life itself contains the same tension. People change continuously, yet retain a sense of identity. Communities evolve while preserving traditions. Generations replace one another while maintaining connections to the past. The stars mirror these patterns on larger scales, not because the universe was designed as a reflection of human life, but because both emerge from processes unfolding through time. And so, as the night approaches its quietest hours, the stars continue shining above the sleeping world, carrying ancient light across immense distances, illuminating the darkness just enough to remind anyone watching that beyond the boundaries of everyday experience lies a universe of extraordinary depth, still unfolding, still mysterious, and still waiting patiently to be explored through the simple act of looking up. Looking up is such a simple action that it is easy to underestimate its significance. The movement takes only a moment. The eyes rise toward the darkness. The stars come into view. Nothing dramatic happens. No great revelation announces itself. No voice emerges from the sky. And yet, throughout history, that simple gesture has altered the course of human thought. Many of the earliest scientific questions began with observations of the heavens. Why do some lights move differently from others? Why do certain stars appear during specific seasons? Why does the moon change shape? Why does the sun follow a predictable path across the sky? These questions emerged not from laboratories, but from ordinary observation. Someone looked upward and noticed patterns. From those patterns came calendars, navigation, mathematics, astronomy, and eventually entirely new ways of understanding humanity's place within the cosmos. The stars have always rewarded attention, not because they actively reveal secrets, but because nature itself contains structure waiting to be recognized. For thousands of years, people believed Earth occupied the center of creation. The stars appeared to revolve around it, reinforcing that impression. Then, gradually, observations accumulated. New evidence emerged. Better measurements became possible. The picture changed. Earth was not the center. The sun was not the center. Even the Milky Way was not the center. Again and again, astronomy expanded the known universe and displaced assumptions about humanity's position within it. Yet something interesting happened during this process. Many feared that a larger universe would make human existence feel less meaningful. Instead, for countless people, the opposite occurred. The cosmos became more fascinating precisely because it was larger than expected. A universe containing billions of galaxies seemed more wondrous than a smaller one. A sky filled with countless stars became more beautiful, not less. Meaning did not vanish with scale. Wonder expanded alongside it. Perhaps this reveals something fundamental about curiosity itself. Human beings are not only comforted by familiarity, they are also energized by mystery. The stars provide both simultaneously. They are familiar enough to recognize, mysterious enough to remain compelling. Even after centuries of observation, the night sky continues offering new discoveries. Astronomers regularly identify previously unknown planetary systems. They observe stars behaving in unexpected ways. They detect unusual signals requiring explanation. The universe remains active, surprising, and resistant to complete understanding. And perhaps that resistance is valuable. A fully solved universe might feel smaller somehow. Instead, the stars continually remind us that knowledge has horizons. Beyond every horizon lies another. One particularly fascinating horizon involves the future of stars themselves. The universe we observe today is not permanent. Stars are being born and dying continuously. But the overall stellar population will change dramatically over immense timescales. Billions of years from now, many of the bright stars visible tonight will be gone. Constellations will look different. The Milky Way will have evolved. New stars will occupy regions currently empty. Others will have faded into stellar remnants. The night sky of the distant future will not resemble the sky familiar to modern humanity. Yet future observers, wherever they might exist, will likely experience similar feelings beneath their own stars. Curiosity, perspective, wonder. These responses may arise naturally whenever conscious beings encounter vastness. The stars seem particularly effective at evoking them because they combine scale with visibility. Many cosmic phenomena are too distant or abstract to perceive directly. Stars are different. They announce the existence of the larger universe in a form accessible to the naked eye. Every visible star is evidence that reality extends far beyond Earth. Every point of light hints at distances and histories difficult to imagine. The night sky functions almost like a doorway between ordinary experience and cosmic awareness. Not a physical doorway, but a conceptual one. It reminds observers that daily life unfolds within a much larger context. And that context is astonishing. Consider the journey of our own sun. At this moment, it moves through the Milky Way, along an orbit around the galactic center. One complete circuit requires roughly 225 million years. The last time the Sun occupied its current position in the galaxy, dinosaurs had not yet appeared. By the time it returns here again, Earth's continents will be altered dramatically. Entire ecosystems will have evolved. Species will come and go. Human civilization, whatever form it may take, will be transformed beyond recognition. Yet the Sun will continue its journey. The galaxy will continue rotating. The stars will continue shining. Astronomy constantly reveals processes operating on scales that dwarf ordinary experience. Yet, rather than making human life seem insignificant, these scales often make it feel extraordinary. After all, consciousness exists only within the present moment. The stars may endure for billions of years, but they do not experience those years. Human beings do. A single evening beneath the stars may be brief by cosmic standards, yet it contains awareness, reflection, memory, and meaning. Duration alone does not determine value. The universe appears to contain many forms of existence, each operating according to different rhythms. Stars embody endurance. Planets embody stability. Living organisms embody change. Conscious minds embody experience. Together, they create a reality far richer than any single perspective could capture. Perhaps this is why stargazing often feels both humbling and uplifting at the same time. Humbling because it reveals immense scales beyond human control. Uplifting because it demonstrates that human awareness is capable of engaging with those scales. A person standing beneath the night sky cannot reach the stars physically, but through understanding, imagination, and observation, the mind can travel astonishing distances. This ability has always been one of humanity's defining characteristics. The stars inspired myths, then measurements, then theories, then spacecraft, each stage built upon the simple act of looking upward and asking questions. Curiosity became exploration. Exploration became knowledge. Knowledge revealed new mysteries, and the cycle continues. Somewhere tonight, perhaps in a remote observatory high above the clouds, astronomers are collecting light from distant stars. Computers analyze data. Telescopes track subtle motions. Researchers search for patterns hidden within enormous datasets. At the same time, elsewhere, someone may simply be sitting outside in silence, watching the stars emerge one by one after sunset. Both are participating in the same ancient relationship between humanity and the sky, one through science, one through observation, both through attention. And attention, perhaps more than anything else, is what the stars invite. Not urgency, not certainty. Attention, to notice, to observe, to remain present long enough for perspective to emerge. The stars do not demand interpretation, yet they reward contemplation. Their light crosses unimaginable distances only to arrive in moments of quiet awareness. And there, in that meeting between ancient photons and present consciousness, something remarkable occurs. For a brief time, the vast history of the universe intersects with a single observing mind. The stars continue their patient burning. The galaxy continues its slow rotation. Space remains immense beyond comprehension. Yet somehow, within all that vastness, there is room for a simple human experience. Standing beneath the night sky, looking upward into the darkness, and feeling connected to a universe that is at once unimaginably large and profoundly familiar. That feeling of familiarity is worth lingering on, because in many ways it is unexpected. The universe is not designed around human scales. Stars are vastly larger than people. Galaxies are vastly larger than stars. The distances between celestial objects exceed ordinary imagination. By every measurable standard, the cosmos should feel alien. And yet, when people stand beneath a clear sky, the experience often feels strangely personal. Perhaps this is because the stars have accompanied humanity for so long, long before written records, long before agriculture, long before cities. Human ancestors looked upward and saw many of the same patterns visible today. The constellations may have carried different names, and the stories attached to them may have varied from culture to culture, but the stars themselves remained. They formed a kind of continuity stretching across generations. Every child born beneath the night sky inherited the same celestial landscape that countless others had seen before. This continuity is rare. Most aspects of human life change rapidly over time. Technologies evolve, languages transform, customs shift. Entire ways of living can disappear within a few centuries. The stars endure, not permanently of course, but long enough to bridge immense spans of human history. In that sense, the night sky acts almost like a shared memory extending beyond individual lifetimes. A person can look at a bright star and know that people thousands of years ago saw that same light. The thought is simple, yet powerful. It creates a subtle connection across time. The stars become witnesses, not conscious witnesses, but enduring presences that have remained visible through countless human experiences. Wars have been fought beneath them, peace treaties signed beneath them, children born beneath them, songs written beneath them, journeys begun and completed beneath them. The stars did not participate in these events, yet they formed part of the backdrop to all of them. And because of that, they often feel woven into the story of humanity itself. This relationship becomes even more interesting when viewed from the perspective of modern astronomy. The stars appear constant, but the sky is not truly fixed. Over thousands of years, stellar motions slowly alter familiar patterns. Constellations gradually deform. New alignments emerge. Old ones fade. The changes are so slow that individual observers rarely notice them. But over long periods they become unmistakable. The sky of the distant past was slightly different from today's sky. The sky of the distant future will be different again. Even permanence, it turns out, contains motion. This idea appears repeatedly throughout the universe. Things that seem stable often conceal gradual transformation. A coastline shifts grain by grain. A mountain erodes stone by stone. A forest changes tree by tree. A star evolves atom by atom. Nature rarely stands still. Instead, it moves at different speeds depending on scale. Human attention tends to focus on faster processes because they are easier to notice. The stars invite awareness of slower ones. They encourage thinking in centuries, millennia, and eons, rather than days and weeks. There is something calming about this expansion of timescale. When attention broadens, immediate concerns often lose some of their intensity. Problems remain real, but they occupy a different position within a larger perspective. The stars do not solve human difficulties. They simply remind observers that reality extends far beyond them. And that reminder can be surprisingly comforting. Not because it diminishes human experience, but because it places that experience within a wider context. A single note gains meaning within a larger piece of music. A single page gains meaning within a longer story. A single life gains meaning within a broader continuum of history, nature, and cosmic evolution. The stars illuminate that continuum. Every star visible overhead belongs to a narrative much older than humanity itself. Some formed before Earth existed. Others may continue shining long after Earth is gone. Their histories stretch across durations difficult to comprehend fully, and yet those histories intersect with ours through light. Light is the great messenger of astronomy. Without it, the universe would remain largely hidden. Everything known about distant stars begins with light reaching Earth. Astronomers study its color, intensity, polarization, timing, and countless other properties. From these clues, they reconstruct events occurring across vast distances. It is remarkable how much information can travel encoded within light. A beam leaving a star carries evidence of temperature, composition, motion, and age. It becomes a record of physical conditions preserved across space. When that light finally arrives, it allows observers to glimpse places they can never visit directly. In this sense, starlight functions almost like a bridge between worlds. Not a bridge for travel, but a bridge for understanding. The stars communicate through light, and the universe becomes knowable because that light can be interpreted. This relationship between observation and understanding has transformed astronomy into one of humanity's most successful scientific endeavors. Yet, despite all the equations, instruments, and discoveries, the emotional experience of stargazing remains remarkably unchanged. People still feel wonder. They still feel curiosity. They still pause beneath clear skies and allow their thoughts to wander outward. Science has explained many mysteries, but it has not removed awe. If anything, it has deepened it. Knowing that stars are powered by fusion makes their light more extraordinary, not less. Knowing that galaxies contain billions of suns makes the night sky feel larger. Knowing that the elements in human bodies were forged within ancient stars creates a connection that earlier generations could only imagine. The universe has become more intimate through understanding. Not smaller, not less mysterious, more intimate. Because science revealed that humans are not separate observers looking into an unrelated cosmos. They are participants within it. The atoms composing every living person share origins with the stars themselves. The distinction between observer and observed becomes less absolute. The universe studies itself through conscious beings. That idea may sound philosophical, but it emerges naturally from astronomy. Stars produced the elements necessary for life. Life evolved awareness. Awareness learned to investigate the stars. A cosmic cycle closed upon itself. And somewhere within that cycle lies one of the most beautiful aspects of stargazing. It transforms an ordinary night into an encounter with deep history. The stars overhead are not merely distant objects. They are evidence of processes unfolding across billions of years. They are reminders that the universe existed long before any observer arrived and will continue long after. Yet, for a brief time, in the quiet hours between sunset and dawn, those ancient processes become visible. A person steps outside, the air cools, darkness settles across the landscape. The first stars appear, then more, then hundreds, and gradually the sky fills with light that has traveled extraordinary distances simply to arrive in that moment. The observer stands beneath it all, neither at the center of the universe nor separate from it, but part of the same unfolding story. And overhead, beyond the reach of cities, beyond the passage of generations, beyond even the limits of ordinary imagination, the stars continue shining with patient brilliance, carrying forward a cosmic history written in light, time, gravity, and silence.